Today, in section 5.5, we want to calculate the area of a region bounded by two graphs. The general idea of finding the area of a region bounded by two graphs is to subtract one integral from the other, and let's explain why. As you can see here, we have two functions, f and g. G is in purple, f is in black, and if we want to find the area of the region bounded by f and g, what we need to do is first we need to calculate their points of intersection. So here their points of intersection are a and b, but assuming we've already found those, we take the integrals of f and g and subtract the smaller from the larger, and here's why. The integral of g between a and b is the area under g between a and b, which looks something along these lines. And then the integral under f is the area under f between a and b, which looks something like this, plus this area down here. And so if we take the integral of f and subtract the integral of g, we essentially ignore all this stuff because we're subtracting the integral of g, and so we're left with just the area between f and g. So let's see how that might look in an example. All right, we want to find the area of the region bounded by y equals x squared plus 2 and y equals x for 0 less than or equal to x less than or equal to 1. So that means we have left and right bounds of x equals 0, which is right here, and x equals 1, which is right here. And in order to find the area between the two functions, what we're trying to find is this area here. So, like I said earlier, what we'll do is we'll take the integral from 0 to 1 of one function minus the other. And to figure out which function we want to be subtracted from the other, we want to let the higher function, so like literally the function that's higher here on the graph, so in this case y equals x squared plus 1 is higher than y equals x. And so what we want to do is we want to take the integral from 0 to 1 of x squared plus 1 minus y equals x. This is all with respect to x. So again, to reiterate what we're doing here, we're taking the integral from 0 to 1, because those are our left and right endpoints. So the integral from 0 to 1 of our bigger function, so that's y equals x squared is our bigger function, minus our smaller function. So here y equals x is our smaller function. And now we calculate. So the integral from 0 to 1 of x squared plus 1 minus x is x cubed over 3 plus x minus x squared over 2, evaluated from 0 to 1. And that works out to be 1 cubed over 3 plus 1 minus 1 squared over 2 minus 0 plus 0 minus 0. So we can ignore all that for now. And this leaves us with 1/3 plus 1 minus 1/2, which that comes out to be, let's see, 4/3 minus 1/2. We can get a common denominator here of a 1/6. So this works out to be 8 over 6 minus 3 over 6 equals 5 over 6. And that's your final answer. For this example, we want to find the area of the region bounded by the graphs of y equals 2 minus x squared and y equals x. Here we are not given left and right endpoints like we were earlier. We have to find those endpoints, and the way we find those endpoints is we find the points of intersection. So the two graphs here, they intersect at this point here and this point here, and we can find those points by setting the functions equal to each other. So if we set x equal to 2 minus x squared, we can find where these two things intersect. So we can rearrange this function by adding x squared to both sides and subtracting 2, and we get x squared plus x minus 2 equals 0. And so this breaks apart to be x plus 2 times x minus 1 equals 0. So this tells us this is at x equals -2 or x equals +1. So those are our left and right endpoints. So what we're going to do is we're going to take an integral from -2 to 1 of the bigger function minus the smaller function. And on this region bounded by x equals -2 and x equals 1, the bigger function is this curve here, which is 2 minus x squared. And so we have the integral from -2 to 1 of 2 minus x squared minus x. And again, we're subtracting off x because y equals x is the smaller function. And this is dx because it's all with respect to x. So let's calculate that integral. This gives us 2x minus x cubed over 3 minus x squared over 2, evaluated from -2 to 1. And so we get 2 times 1 minus 1 cubed minus 1/2. That whole quantity minus 2 times -2 minus -2 cubed over 3 minus -2 squared over 2. And so let's simplify this a bit. So we get 2 minus 1/3 minus 1/2 minus -4 minus -8 over 3 minus 4 over 2. So we can distribute this negative in here, and this works out to be 2 minus 1/3 minus 1/2 plus 4 minus 8 over 3 plus 2. And then again, that's because 4 over 2 is 2. So here we collect our like terms. We get 8 minus 9 over 3 minus 1 over 2. And so now we find a common denominator, and here our good common denominator is 6. So this gives us 48 over 6 minus 18 over 6 minus 3 over 6. And that works out to be 27 over 6, which is 9 over 2. And that's your final answer.